In this video, we're going to look at finding the area inside a certain polar equation, r equals 3 sine theta, and outside a different one, r equals 2 minus sine theta. So we have this graph here, and we have the purple one and the red one. All right, so we want to be inside the red graph and outside the purple graph. So we want to be inside this circle and outside this graph right here. So let's take a look at that area we want first. Looks like we're going to be trying to find this area right here. Alright, so basically what we need to do is we need to find the area inside the circle, and then we're going to subtract out this area right here. And we can do that with one formula. If you remember the formula for area inside a polar curve from alpha to beta is 1/2 f of theta, or r, quantity squared d theta. Alright, so we want to find this area inside the red circle and outside the purple circle, so we want to subtract this purple, I shouldn't call it a circle, purple graph out. So we're just going to subtract out this area right here. Let's call this g of theta. So we're going to do alpha to beta 1/2 of f of theta squared, this whole thing squared, another bracket, that's okay, we'll do this. This whole thing squared minus the other function squared d theta. Okay, so that's basically what we're going to do in order to find this area. Alright, so it helps to look at the slide here and think about the area. Actually, let's go back to this one first, little bigger picture. So here's our alpha, is this angle right here, whatever this point is. This is our alpha. And then this is going to be, this angle here is going to be our beta. So we have to figure out the coordinates of these 2 points to figure out what alpha and beta are. Now, if you remember, the theory behind this is you're finding the area of these sectors. So we could draw these sectors, and we're letting the number of sectors go to infinity. And so what you're really doing is you're subtracting the area of this sector minus the area of this sector. And we're going to do an example next where it's a little bit more complicated than that, but if I draw all these sectors all the way over to here, we can see that we're going to have the red polar equation minus the purple one for every single sector between alpha and beta. It's not always like that, so it's going to get a little trickier. Dot, 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 all these sectors. All right, so first thing we have to do is figure out these points of intersection. So we want to figure out where these two equations intersect each other. So we want to figure out, where does 3 sine theta equal 2 minus sine theta? Well, it shouldn't be too hard. All right, so we'll add sine theta over there. Divide by 4 and reduce that. It's going to give us 1/2. So where does sine equal 1/2? So hopefully you remember your unit circle and all that good stuff. So sine's going to equal 1/2 at 30 degrees, or pi over 6. We'll just stick with radians here. 30 degrees, and then over here the sign is also positive. In the second quadrant, it's going to be 180 minus 30 degrees, or 150, or pi minus pi over 6, which is 5 pi over 6. So these are our 2 points. This is going to be our alpha and our beta. So we're going to want to do the integral from pi over 6 to 5 pi over 6 of 1/2 times the outside circle here, the red one, 3 sine theta, and then this whole thing squared, minus, and then this purple part. So the purple equation is 2 minus sine theta, quantity squared, d theta. And that's the setup. All right, that's pretty much the end of the polar setup. The rest of this video is going to be solving this integral, and if you feel really comfortable solving this integral, it's going to involve some trig substitution. You might want to just fast forward to the end and see if you got the right answer. But for the sake of practice, I'm going to go ahead and go through all the steps of solving this integral. All right, so we have our choices with the half. We could pull that out in front or not. Let's just go ahead and pull it out front. All right, so the first thing that we're going to need to do is simplify this all out. So we're going to get 9 sine squared theta minus, and I'm going to FOIL this out, it's going to be 4 minus 4 sine theta plus sine squared theta d theta. All right, I just copied that to a new slide. So we have 1/2 pi over 6, 5 pi over 6. Let's see what we've got here. Looks like we can distribute this negative and combine these sine squareds together. So we have 9 sine squared minus sine squared. That's going to give me 8 sine squared. And then plus 4 sine theta minus 4. Now, this integration is not too tough except for this sine squared theta. So we have to remember a trig identity, which you probably remember or can look up as cosine of 2 theta equals 1 minus 2 sine squared theta. And we want this because when we're doing integration, we can integrate with the 2 thetas, just a little u sub, but the sine squared is, we can't integrate that. So if I solve this for sine squared, and I'll let you do this if you want to work it out, you get 1/2 minus 1/2 cosine 2 theta equals sine squared theta. All right, so I'm going to make that substitution over here with this sine squared. So that's going to end up being 1/2 minus 1/2 cosine 2 theta. All right, and that's going in for this sine squared theta here. So I'm going to have to distribute that 8 in. All right, let's see what we've got now. We still have our half. Going to get to the integration pretty soon here, hopefully. So 8 times 1/2, and then 8 times 1/2. I think we're almost ready to integrate. Maybe these 4s will drop out. That'd be nice. A little bit less work. All right, so it looks like these 4s are going to drop out. I'll just go ahead and kind of cross them out here. And then we'll go ahead and do our integration. Looks like we're ready. Okay, so take the integral. I'm going to get 1/2. And so you need to do a little u sub here, right? If you remember, if you let u equal 2 theta, then du equals 2 d theta, and so you kind of balance that out with by putting a half here. However you learn, there's a couple ways to do it, but hopefully you've done that at some point. So we'll have -4 times 1/2 sine 2 theta plus 4 times negative cosine theta, antiderivative of sine. And we're going to evaluate that from pi over 6 to 5 pi over 6. Maybe we'll clean that up a little bit. All right, so that's going to give us, and we can distribute the half in here if you want to make it a little nicer at this point. So these have, this will give us negative sine 2 theta. Let's see, half of 4 is going to be minus 2 cosine theta. We're going to evaluate that from pi over 6 to 5 pi over 6. All right. So we'll put our 5 pi over 6 in. So we'll have negative sine of 10 pi over 6, which is 5 pi over 3, minus 2 cosine 5 pi over 6, minus negative sine 2 times pi over 6, so pi over 3, minus, lots of negatives here, 2 cosine pi over 6. All right, we're almost there. Let's see, sine of 5 pi over 3. So I just pulled in this little unit circle here. It's pretty small, but at least it gives you a visual. So remember 5 pi over 3 is in the fourth quadrant. Pi over 3 is 60 degrees. So 5 pi over 3 would be 300 degrees down here. So the sign is negative. So it's going to be negative root 3 over 2. See, I'll get my blue color back. So we have negative root 3 over 2. All right, 2 times the cosine of 5 pi over 6 is over here. 5 pi over 6 is 150, so the cosine's negative root 3 over 2 as well. That's going to be a plus. Sine of pi over 3. So pi over 3 is 60 degrees here. That sine is root 3 over 2. Minus 2 times cosine pi over 6. Pi over 6 is 30 degrees, so that's root 3 over 2. All right, let's see what we've got. So we got square root 3 over 2 plus, those are going to cancel, so square root 3 plus square root 3 over 2. Those twos are going to cancel. Oh, I think I lost a negative here. Right here, minus a negative, that makes a plus. Right here, minus a negative. Okay, so those cancel, and that gives me root 3. And so these two are a half root 3, and a half root 3 is going to make 1 root 3, 2 root 3, 3 root 3. Whew, we did it. All right, 3 root 3 is our answer. So if you remember where we started, we were trying to find the area between these two curves, or outside the purple curve and inside the red curve. So this area in here is 3 times the square root of 3. Right? And we did that by subtracting the area, and we got this formula from these sectors, right? So we're subtracting the red and then minusing the purple area inside the purple curve, right? We set that up here, and then that was just a lot of integration and trig sub and special angles and trig identities, and so there's a lot going on here to get to the end, but hopefully you remember the big picture of where we started.